Hello, it's Photon again. Uh, I thought I'd make this generic tutorial for converting and playing a song using the play routine for the player 6.1.0.9 or whatever version sequence they use. So this is the same version as 6.108, only cleaned up a bit. I fixed the case sensitivity issues, made a couple easy to use modes, which I thought I'd use and show you. So the first thing to do when your musician sends you a module is to play it in Protracker, and you should use one of the reference versions, 2.3D or 3.15. Because these are the versions that the play routine is compatible with. The reason you should play them here first is to hear what they sound like, right? So that if there are any conversion errors, you will hear them. So you don't release a demo with a faulty song in it. So we only have the one song, the one we made in the previous tutorial. So that's sort of kind of how it starts. And what you should do is resave it, right? I don't have to do that because I made it in Protracker 3.15, but a lot of trackers have been made for the Amiga and the PC and so on since then. And a newer version of an effect command may have been sneaked into the module, and we'd like to resave the module to let Protracker 3.15 first check that it sounds correct in Protracker 3.15. If it doesn't, then it's not Protracker 3.15 compatible. Ask your musician to listen to it in this Protracker version and correct any things that sound wrong and send you a new module, or correct them yourself if you're good at Protracker. Either way, make sure it sounds correct, then resave it to let Protracker 3.15 rinse out any strange bytes in the module file that could make the player converter throw up basically, or convert it incorrectly. So now we have a clean module in this directory, so we need to convert it. So we've checked the module that it sounds correctly, then we've saved it in Protracker 3.15. Now we convert it. Convert Protracker modules. Sorry about only having two colors in my CLI screen here. Either way, this is the directory we saved it in. Just load that, and it will ask for a name like that, and I'm going to make sure that there's an underscore there, and I'm going to put it in a temporary directory that I have there, and save it, and watch as your module size shrinks. And there you go, and take note of this use code. You will save a lot of CPU time if you specify this instead of the catch-all use code of -1. I'll show you this now. So in sys:'T there's a module called this and that, and oh, I want to show you the preferences as well. I've unchecked everything except tempo. We're not interested in delta converting our samples. We're not interested in exporting a song with no samples in it. You can separate them into two files. You can add a signature, you can generate an icon, and you can pack the samples. I'm not that sure that the playroutine was finished to pack the samples. Either that, or it expects the programmer to use some standard impulsive decompression routine or something. Anyway, these are the settings. So let's head into ASM1, and if you download the player 6109 from the link in description and unzip it or decompress it anyway into its own directory, then you get these files. And I've simplified it so that you only have the one include file and the one example source. You have a README, you have two example modules, and you have the converter. That's what's in the archive. And note for this new ditty module that it has, if you use the list command, you can see the file comment which contains the use code. As you can see for this song, it doesn't always transfer across file systems for some reason. Either way, that's the use code, so we can check it later. And we're just gonna jump into let's see if you spell it right. What you do is you just load the example source, assemble, and run. So that's how it should work, right? That's playing the example song. That just happens to be the same module as the one I used in the example to convert. That's a coincidence. I couldn't find any. What I wanted was a module that used the so-called CAA mode, which uses a custom tempo. You remember these F values, high F values instead of F0, 6, and so on. I wanted that, and I wanted it to use some E commands and some stuff to you know be a good demonstration module. I had a lot of fun today listening to a lot of modules recommended by friends, by Mantronics and Banana and all kinds of nice musicians. None of which contained custom tempo. I had a look at some other modules as well, but I just couldn't find one that fit the bill as well as this one. So sorry for the self-promotion, but it's a good example module. I was delaying the release by hours listening to a lot of songs. Anyway, that's one of the example modules. Now let's try the other. Go to the bottom and just use this one instead. And that's a very simple module, as you could hear. It's only 2 patterns, I think, and it doesn't use the custom tempo, which makes it a good example song for some of the modes that I've created for the play routine. So simply, let's have a look at the first one again and see what we're seeing and what the options are for this. And let's check the source here. I've basically haven't changed that much. I've changed the names of some variables, and I've fixed some case sensitivity issues and operators issues and so on, so that it should be more compatible if you don't use the ASM1 assembler. It can be used in 4 modes. In the history of module play routines, there has always been 2 modes, CA mode and V-blank mode. V-blank mode was for the simpler times before, I would say before 1991 or somewhere thereabouts, where not many used the CA mode because they were asked by their democoders that they wanted to call the play routine once per frame at a certain raster position, so that they would, when the CPU was not being outcompeted by the blitter and so on, and to keep things simple. And maybe that's the reason almost all musicians never use custom tempo. Maybe there's another reason, I don't know. That's the VBlank mode, and the CA mode is the default mode for this play routine because it supports everything. Anything you can play in Protracker 3.15 you can play with this mode, and the only thing that's different is this tempo command. So that's the safe default, you could say, which is why it's set to this to begin with. And what it does is, when the CIA mode is active, then the play routine runs on interrupts, which means that it will be called at different positions on the screen, different raster positions each time. It may be called more often than 50 Hertz, or once a frame. It may be called less often than once per frame, depending on your speed setting. And it's handy for the most part. It's a bit more tricky to start and interrupt and so on, but the play routine takes care of that. Simply it plays on the interrupts in the background, and you can do whatever you want, but you have less anal control of CPU cycles. So if you have lots of CPU cycles, such as if you have not made any spectacular effects, or if you're using a fast CPU, then it's a no-brainer. Always use this. Anyway, I've added two more modes. Both of these are considered VBlank modes in that respect, that they're called once a frame and are incompatible with these custom tempo commands. The copper mode times the setting of the sound DMA when an instrument is triggered, by poking a copper that you specify, a copper address. And this copper address should be in the copper 11 scan lines lower down than the call to P61 music. That's handy because this whole example, which is taken from the original play routine, sort of does a VBlank frame loop with a copper interrupt request polling loop, which I will show you. And in the copper mode, what you save is this extra interrupt that is triggered 11 scan lines after the main play routine code has finished setting up the DMA registers, and then after a bit of time it triggers this secondary interrupt that sets the DMA for these two modes. In copper mode, it pokes a DMA value in the copper. It's very simple. And the fourth one is a maximum optimization mode, which adds some requirements to the module. So it's easy to get going and get your song played. What I want to show you before we go into the details of running these other modes is this, how to optimize it for mode 1, which is, firstly, when you play this song, you can see how much raster time it takes. It takes between I guess 4 and 8 scan lines on a 68,000 CPU. But there is no really good way of measuring these. I think there's two chained interrupts, and then the secondary interrupt which just sets the DMA. So there's no good way of measuring that, but we can make sure that it plays optimally by, firstly, one of the biggest CPU time gains is setting the use code, and this will also cut down on the playroutine code size. I'm from memory, I think it's somewhere around 5K. So you will save lots of bytes by setting the use code, and you will also save raster time. So let's check the use code. Copy that. So I have a note here that really alerts you that you should change this use code, and there are instructions if you use the same playroutine for multiple songs in the same demo. You just OR with the exclamation mark, you OR the use codes together. So that's it. And also there's this split 4. This overrides this setting, which we already used. That means that we have split up one channel to be decrunched at 1 frame later when the playroutine is less busy triggering instruments, starting effects, and so on. So there's already an optimization there, but this will give the maximum optimization as far as split channels is concerned. It splits all the channels. It's incompatible with these F speeds. You can't have any of these in the song for this to work. And since I know the song, I know it doesn't have those, so it will work with split 4. And we can't see the gain, but you should have gained roughly between 1 and 2 scan lines. Probably 2 scan lines on the maximum CPU time consumed there. So these are the optimal settings for this module. We can change them back and switch module. And your module absolutely does not have to be as simple as this to fit in this category. All that's required is that it doesn't use this custom tempo, these high F values, for you to be able to go to mode 2, 3, and 4. So this is mode 2, which is the standard VBlank mode that a lot of you might recognize from the old times of Protracker and Soundtracker playroutines. It calls the playroutine once per frame and sets Alright, so that's how much raster time that takes in that mode. Now if we enable split 4, because I know this module doesn't have these commands either, then we should be able to see a much smoother and more even raster time, CPU time consumption. And we have no sound. Oh, I set it to 4. That's not a good thing. Okay, so set this to 1. Don't set it to 4. Very simple. So let's check that, and let's see how much the use code optimizes away. On my screen that looks like about, I think it was a little over 4 or a little over 5 scan lines. So if we copy this from the bottom the use code. Yeah, we gained about 1 scan line doing that, and we can leave this use code, and we can still have split 4 enabled for the other mode. The only thing this mode adds, is remove what was not included in the tiny sliver of CPU rest time there, was the secondary interrupt, or the callback, which sets the DMA. That takes a few cycles. I mean, first of all, the interrupt has to be generated, has to be responded to. You have to save and restore all the registers. You have to clear the interrupt flags and return. So a couple hundred cycles there, which we didn't see. So this should be no different now. What we did was replace. No major difference, maybe a few cycles, not anymore. What we did was replace the interrupt with a single line in the copper. So in this byte here, the DMA value will be poked, and those bits will be set. So if you're going to use a VBlank mode anyway, then this is just as good as the standard VBlank mode, and you save 1 interrupt. So that's mode 3, and the maximum optimization mode shouldn't really do much on this song either, but you will be sure that not a single cycle is wasted. Generates a source that is about 500 bytes longer. Saves 26 cycles. What else? It requires you to pad instruments that are shorter than 300 bytes for this mode to work. That's to save a retrigger. And that's pretty much all. The only differences. And the difference is barely noticeable. But if you're really strapped for CPU cycles, you can try this maximum optimization mode. So again, then the big savers here was the use code, first of all, and the split options. This already saves quite a bit. This reduces the maximum time consumed by the playroutine and makes it more even, you could say. I guess we could set this back to -1 and try the maximum optimization mode. I haven't tried this at all, but it should work. Yeah, I think that's about 1 scan line more. That's the difference between setting the use code and not setting the use code. So, basically that concludes how to use the playroutine. We can go through the source quickly to just so I can tell you how do you get this into the demo. We'll do this in the next tutorial, but first of all, there's the options here, and if you change mode, then you have the exceptions here for modes 1, 2, 3, 4. And here's where the code starts, and it's pretty much the original code. It's a compatible startup, so if you want, you can use this source and basically add demo effects and graphics and stuff to it. It's certainly better than well, I would say it's not as simple, but it's more capable than the startup init and exit code we have in our demo right now. I won't go into detail about that because we're not really there yet when it comes to the more advanced library calls and so on. I want to talk about the init. So what you do is you copy, first of all, the relevant options to the top of your demo source. And then you must, before you start your demo, you must call p61 init. And it requires the following registers to be set, not this one. This I've just added in case you want to use modes 3 or 4. If you don't, then you don't need this. It's harmless if you leave it in. Basically, all these are dud values, and only this matters. You need to clear A2 because otherwise it will go looking for samples in another place in memory. But otherwise, it should look like this. Starts the copper. Here's our frame loop. And instead of waiting for raster position manually with the CPU, it waits for the copper to set an interrupt request bit. So it polls that and keeps repeating that, and that's what makes it sync to a certain vertical raster position on the screen. And as I said, in p61 mode equals 1, in other words, in the CIA mode that supports these custom tempo values, then I don't change the background color to show the CPU raster time consumption, and also I don't call p61 music. You should never call this in your frame loop if you're running the play routine on interrupts in the background, right? It's pretty simple. If you do this, you will get 50 notes per second, which sounds very fast, so don't do that. And here's where you can insert your demo code if you want, and here's the wait for the left mouse button, and when we've exited, we wait for the blitter, and this is not very compatible, I see. So you have to test this register first. You can add that as an exercise if you want. The play routine, by the way, doesn't use the blitter, of course. It's if you put some cool stuff in your play routine. So it's really unnecessary. And after you've exited, you end the music, and this is the startup exit code to return to the system. So here's where your the play routine is inserted. It's a simple include file. If you want, you can add stripped here to save about 20k of commentary. So there are both versions in the archive. Assembles a bit faster. And here's our copper list, and all it does is turn off the bit planes, set a background color, wait for a specified raster position, trigger flag an interrupt request, wait for 11 scan lines more, and then has this poke address, cop poke plus 3, which is this byte, which is used in modes 3 and 4 to set the DMA. You can, even if you don't use modes 1, 3 and 4, you can leave this in. It does no harm. And this is the end of the copper list. And here's where you include your module. The copper and the module must be in chip memory, of course, and that's pretty much it. Anything else? Well, when you use this play routine in your demo, as I said, you copy the relevant options. You copy the options common to all p61 modes, and depending on your p61 mode, you also copy these options, and then you're done. You put that in at the top of your source. or at least before you include the playroutine source. All of this, of course, will be replaced by your demo and your frame loop. If you have your own frame loop and you use P61 mode, P61 mode equals 1, in other words the CAA mode, you should not call P61 music, as I said. So you can leave your frame loop as it is. And make sure that you call P61 end when you exit your demo or when you want the module to stop playing. And then at the bottom of your demo code, include this source. If for some reason you need to put this source in a separate section, you have to calculate the address using these variables to call them instead, but that's advanced. Finally, use your own copper, and only if you use P61 mode 3 or 4 should you add these 2 lines. 11 lines, and this wait, 11 lines after the raster position where you call P61 music. Include the module in some chip section and you're done. That's it.